So question 36 is a continuation of question 35, so if you haven't watched 35 yet, I'd watch that one first because we're going to use some of the figures that we got from 35 and 36. So 36 starts out, it has three parts. It wants to know part A, part B, and part C. So part A wants to know the angle at which the boat needs to sail in order to reach the shoreline directly east of where it started. And we know that the speed of water relative to the earth is equal to 2, so we can erase that. And we know that the speed of the boat relative to the water is 4.2. So we know that. What we want to know is, for part B, is going to be the speed of the boat relative to the earth. And then part C wants to know the time it takes to get from one shore to the other. So for part A, we want to know theta. So the way we're going to figure that out is we want to know theta. We know that since these are parallel, this is also theta. So what we're going to do is we're going to take sine of theta is equal to opposite over hypotenuse. So we'll take the opposite over the hypotenuse, 4.2, and so now we can solve for theta by taking the inverse sine of 4.2 is equal to theta, which is 28.4 degrees. So now we know that this is 28.4 degrees. Okay, so we know now theta is 28.4 degrees, and that's going to be north of east, so north of east. So for part B, what it's wanting to know is the velocity of the boat relative to the earth, so the velocity that the boat is traveling east. So we're going to use the Pythagorean theorem to solve this. So we did the Pythagorean theorem, we'd have 2 squared plus velocity of BE squared is equal to 4.2 squared. So we'll just subtract the 2 over, and we get velocity BE is equal to the square root of 4.2 squared plus 2 squared. And that is equal to 3.7. Oh, we can write it right here. 3.7 meters per second. So for part C, it wants to know the time it takes to get across the river. So what we're going to do is we want to first figure out the hypotenuse of this length. So if you remember back from part 35, the river is 500 meters wide. We know that this is 28.4. So now we can just use the law of sines, and we figure out the hypotenuse length is 800 meters. And since we know we're traveling, the boat relative to the earth is traveling at a speed of 3.7 meters per second, we just go 800 divided by 3.7, and we punch that in the calculator and get 216 seconds. That's how long it takes to get across the river. So that's part A, B, and C.